everyone, this is Sakshi and I welcome you all to my platform Way to Learn. So, we are going to solve some of the PYQs for GATE exam, and I had already started PYQs for mathematical physics and I have completed 1 to 10 questions. So, in this video, we are going to solve other set of 10 questions from GATE. Okay, so GATE PYQs. So if you haven't subscribed my channel, please subscribe, share, like my videos, and help your friends to solve the problems and solve together. So let us uh, see the other set of 10 questions. We'll start from question number 11, which is from GATE 2004. So if you see here, a real traceless matrix is given. Okay, traceless represents that. Okay, so traceless represents that the sum of eigenvalues will be equal to 0. So I have taken 4 eigenvalues here because we have given in the question 4 cross 4 matrix. Okay, so we have already given like lambda 1 and lambda 2 be plus 1 and minus 1. So lambda 1 is equal to plus 1, lambda 2 is equal to minus 1. So now you have to choose from the option and see which satisfies this particular equation. Okay, so if you add lambda 1 plus lambda 2, you'll get 0. So you're going to add lambda 3 and lambda 4 directly to get the value 0. So 0 plus 2 will be plus 2, plus 1 plus minus 1 will be 0, 0 plus 1 will be plus 1, and plus 1 plus 1 will be 2. Therefore, option B will satisfy this equation. Lambda 3 will be plus 1 and lambda 4 will be minus 1. Therefore, plus 1 plus minus 1 plus plus 1 plus minus 1. This will give you 0. Therefore, option B is satisfied. Now, let us see question number 12, which is from complex analysis and again from 2004. So, we have to find the inverse of this complex number 3 plus 4i and 3 minus 4i. So, here let z is equal to 3 plus 4i divided by 3 minus 4i. So we have to find the inverse. Inverse is nothing but 1 by z. So how can you write this 1 by z as 3 minus 4i divided by 3 plus 4i. So now you have to solve this question. So when you have such real plus complex or the complex number alone, then what you have to do is you have to multiply and divide by the complex conjugate of the denominator. So you have to consider this denominator and multiply and divide by the complex conjugate. So you get 3 minus 4i by 3 minus 4i. So on solving this, you get 3 minus 4i the whole square divided by 3 square minus 4i the whole square. So on solving this, you get 9 minus 16 minus 24i the whole divided by 9 plus 16. So 9 minus 16 will give you minus 7 divided by 25 minus 24 by 25 into I, which, okay, uh, option D satisfies the answer for this question. So therefore, whenever you have any complex number such in the denominator and you don't know how to solve that, then the first step that you have to do is you have to take the complex conjugate. So let us see the next question from again from GATE 2004. This is again from complex analysis, and here we have to find the value of this integral. So let us consider this f of z is equal to integral dz by z square plus a square. Okay, so now first thing they have said that C is a unit circle centered at the origin. So unit circle, this is the unit circle. Okay, So the first step we do always is to find the poles. We equate the denominator to 0. Z square plus a square is equal to 0. Therefore, z square will be equal to minus a square, and you can write z is equal to plus or minus ia. Okay, so now how do you find the residue? You will have to find two residues for plus ia and minus ia. So residue will be z plus ia into 1 divided by z plus ia into z minus ia. So you get 1 divided by minus 2ia. So this is your first residue. Now let us find the second residue. For z is equal to ia, you get z minus ia into 1 divided by z plus ia, z minus ia. I can write this denominator as z plus ia and z minus ia. So that is what I have done over here. So at z is equal to ia, you get 1 by 2ia. Okay. So now what we have to do is you have to find f of z, that is the integral f of z dz will be sum of the residues into 2 pi I. Okay, so the sum of the residues will be minus 1 by 2 ia plus 1 by 2 ia into 2 pi I, which is equal to 0. So without knowing the value of a, you can find the integral f of z dz to be 0. Okay, now you have to see the options first. Which of the following options satisfies your equation? That is your integral answer. Okay, if you see the option, only option B has the answer 0. And sometimes we can get some other answer instead of 0 while solving like this. So what should you do? You have to see if the value given for A lies inside the circle or not. So there are only two values given, A is equal to and A is equal to half. For A is equal to 2, if you see, it does not lie inside the counter. So therefore you are not going to consider A is equal to 2 value. So now when you consider A is equal to half value, you are given two options. A is equal to half and A is equal to half and A is equal to again half. For A is equal to half, 1 is pi by 2, and for A is equal to half is 0. So when you solve that, when you put A is equal to half here, you are going to get minus 1 by I plus 1 by I. Therefore again your answer will be 0. So hence your integral value will be 0 for A is equal to half. So this should be your answer. You always have to check if it lies inside the counter or not. Okay, so let us solve the 14th question, which is again from 2004 Laplace transform. Here we have the function f of t as sine pi t, and the Laplace transform of this function is given as pi divided by s square plus, I'm sorry, I've written wrong here. It's pi divided by s square plus pi square. Okay, so you can check this question again. So it's f of s is equal to pi divided by s square plus pi square. Okay, so now, yeah, yeah. Now this is the Laplace transform for this question. Now we have to find the Laplace transform of uh, L of t sine pi t. We know that L of t f of t is equal to minus 1 the whole power n d by ds the whole power n into Laplace transform of f of t. Right. So know the Laplace transform of sine pi t, and t has power 1. Therefore, for t sine pi t, we can write as -1 the whole power 1 d by ds into pi divided by s square plus pi square. So now we have to differentiate this pi divided by s square plus pi square with respect to s. So when you do that, you get -1 the whole power 1 2s into pi divided by s square plus pi square the whole square into -1. Okay, so when you take the whole denominator, because it's in plus, so when you take the whole denominator, you'll have to write like this. Therefore, L of t sine pi t will be equal to 2 pi s divided by s square plus pi square the whole square, which is equal to the option C. Okay, so let us see the next question, which is question number 15, from GATE 2004, and this is from Fourier series. Okay, not transform, Fourier series. So if you read the question, a periodic function f of x is equal to x. So this x lies between minus pi to plus pi and has a Fourier series representation. This f of x, that is equal to x, has a Fourier representation which is given as n is equal to 1 to infinity minus 2 by n minus 1 the whole power n sine nx. So using this, one finds the summation n squared to be what? Okay. So now we have to remember that we have this sine function with us. Okay, that is x is equal to some sine function. Now you can say that a naught will be equal to 0 and a n will be equal to 0. If you remember, we have a naught term as 1 by uh, integral f of x dx, right? And an isn't is like in terms of cos, right? So therefore, uh, okay. So therefore, we can say that only bn is present because only sine term is present. So only when sine term is present, we can say that bn alone is present, and therefore a naught and an will be equal to 0. So now how do you find this summation n power minus 2, that is 1 by n square? How can we find it? Okay, so the first thing that we have to do over here is you have to think like what all kind of formulas do you remember? Okay, so the one formula which we can use here is the Parseval's formula. Okay, so Parseval's formula for minus pi to plus pi will be minus pi integral minus pi to plus pi f of x the whole square dx, which is equal to pi into half a naught square plus summation n is equal to 1 to infinity a n square plus b n square. Now I can say that my f of x is x over here, so minus pi to plus pi x square dx is equal to pi into, I know that a naught and a n will be equal to 0. If I can say that is equal to b1 square plus b2 square plus b3 square plus b4 square and so on. Okay, so we are going to use the Parseval formula here in order to solve this question. Okay, because we need n square term. We do not have n over here. Even if you consider this n over here, only if you square this you're going to get. So you can't directly square a given function and find the answer. So you're going to use this Parseval's formula over here, and you're going to find the answer for summation 1 by n square. Okay, so now what we have to do is, we do not know bn. we just know that we are having this x is equal to minus 2 by n minus 1 the whole power n sin nx. So if you see this form, you can see that, okay, if you see this form, you can see that this is similar to bn. Okay, or else you can also find bn using the formula 1 by pi minus pi to plus pi f of x sin nx dx. So when you solve this particular equation, you get around like 2 by n minus 1. Sorry. Yeah. When you do this, when you solve this equation with f of x to be x, using this f of x to be x, you're going to get 2 by n minus 1 the whole power n. Okay. So now you can use this b1, b2, b3, b4 using this bn formula. So now we have to find like the LHS, which is minus pi to plus pi x square dx. Since this is an even function, I can write 2 into 0 to pi x square dx, which gives me 2 into x cube by 3, 0 to pi limits, and I get my LHS to be 2 pi cube by 3. So this is my LHS, and I know my RHS to be pi into b1 square will be 4 divided by 1 square plus 4 divided by 2 square plus 4 divided by 3 square, and so on. So I can write this as 4 pi into 1 divided by 1 square plus 1 divided by 2 square plus 1 divided by 3 square, and so on. So if you see this now, you can get the form of 1 by n square, right? So I can write this 2 pi cube by 3 is equal to 4 pi into summation n is equal to 1 to infinity n power minus 2. So on solving this, I get summation n power minus 2 will be equal to pi square by 6. So pi square by 6 is the answer for your question, given question. So which is option C. So let us solve the next question, which is again from Fourier. Okay, this is from Fourier transform. So if you see the questions from complex analysis, from matrices, from Laplace transform, from Fourier series, and now it's from Fourier transform. 5 more sums, and then we'll see we'll complete this set of questions. So we have to find the Fourier transform of the function e power minus x square. So I'm going to give you a new formula in order to solve this question very easily. Okay, so we know that f of k is equal to minus infinity to plus infinity e power I k is f of x dx. Now we have to find the Fourier transform of function e power minus x square. So we can write this f of k as minus infinity to plus infinity e power I k x dot e power minus x square dx. So I can write this as minus infinity to plus infinity e power minus x square plus ikx into dx. Now we can use this formula minus infinity to plus infinity e power minus ax square plus bx dx is equal to root pi by a e power b square by 4a. So this is a new formula. I'm not going to use this particular given gamma function because this is going to take me a very long step in order to complete the solution. So for gate exam, it's for only for 2 marks. So I think this will be better choice of formula. So when you know this formula, you can directly just substitute in the formula. So you get minus infinity to plus infinity e power minus x square plus ikx dx. So here if you compare with this, you get a to be 1 and b to be ik. Okay, so now you're going to use this formula. So root pi by a, which is root pi by 1, which is root pi e power b square. B square is ik square. So e power b square is ik square. Therefore, that is I square k square. I square will be minus. Therefore, minus b square by 4. So, okay, sorry, it's minus k square by 4. Yeah. So, which is equal to option B. So, very easy, simple solution. So, you can use this formula instead of that gamma function because that is a very long process if you use that formula and then solve. But you can use that too. If you have enough time, you can use that too. But if you remember this formula, this is going to help you in other problems too. So let us see the next question, which is simple question, and this is from GATE 2005. So if you see, we have already like done 6 questions from GATE 2004. So this is our 17th question, which is from GATE 2005, and a very easy question because we have to find del cross f. So curl into curl of f or curl into curl of any function will be 0. That is a standard equation that you have to remember. Curl of any function will give you 0. Therefore, del cross f will be 0. You can also try, you can use del cross f, first find the curl of f and then again find the curl of that particular answer. You're going to get 0, which is option A. So next, let us see 18th question. We have to find the solution of e power z is equal to minus 3. So this is a very easy, simple solution. You have to find z is equal to what? Because all the option has z is equal to something. So you can, first thing you can write e power z as minus 1 into 3. You can write minus 1 as e power 2n plus 1 I pi. For n is equal to 0, 1, 2 and so on. 0 plus or minus 1 or plus or minus anything. Okay. So now I can write this e power z is equal to e power 2n plus 1 I pi into 3. Now taking ln on both sides, I get e power ln 3 plus 2n plus 1 I pi for n is equal to 0 plus or minus 1 plus or minus 2 and so on, which is equal to option 3, option B. So this is a simple solution. You just have to know what is the exponent form of minus 1. So if you don't know, please note this down. Now question number 19 is very simple again. So we have to find, we have given 4 vectors. So u1, u2, u3 and u4. We have to find the linearly dependent pair. Okay, linearly dependent means one pair, that is one vector will be dependent on other vector. Okay, so I can write this u1 vector as I vector plus 2j vector plus 3k vector, u2 vector as 3i vector minus 5j vector plus k vector, u3 vector as 2i vector plus 4j vector minus 8k vector, and u4 vector as 3i plus 6j minus 12k. Okay, So now you can see that I can simplify this as when I remove 2 over from here, I get I plus 2j minus 4k. And similarly, when I remove 3 from over here, I get I plus 2j minus 4k. And then you can easily solve this too. So on solving this, you get u4 is equal to 3 by 2 of u3 vector. So I can see that even if I have u3 with me, with this relation, I can find u4. Okay, u4 is not a unit vector like u1 and u2. Only when I have u1 vector with me, I can write this u1 vector. Using u2, I cannot do anything. I cannot write anything about u1. And using u2 or u1, I cannot write anything about u3 or u4. But using u3 or u4, I can write about u3 or u4. Right. So therefore, only these two pairs are linearly dependent pairs. That is, u3 depends on u4 or u4 depends on u3. Whereas u1 and u2 doesn't depend on any other vectors. So u3 and u4 are the linearly dependent pairs. So let us see the last question of the day. So here we have to find which of the following functions of a complex variable z is not analytic. Not analytic. So you have to remember what is analytic over here now. So when you substitute any real number in the place of z, okay, when you substitute any real number in the place of z and you get a finite value. So if I say that you have z square, now you're going to substitute z is equal to 0 to uh, before infinity. Okay, 0 to up to 10. So these are all real values. So on substituting those, you get z square is equal, like for 0 you get 0, 1, 4, 9 and so on. So therefore when you substitute any real value, you're going to get a finite value for that function. So it means that the function is analytic everywhere for the given real values. But if it is non-analytic, that is when you substitute any real values for the given function and the answer is infinity. If your answer goes to infinity, then that function is not analytic. So if you see e power z for all real numbers, it does not tend to infinity. Therefore, this is analytic. And e cube, there is no z term over here, so this is real. And z cube, so this will z cube will also be analytic. Okay, only sine z by z is not analytic. Why? Because when you put z is equal to 0, sine 0 by 0. So anything divided by 0 will give you infinity. So therefore, this is not analytic. Therefore, option B is not analytic everywhere for given real values. So thank you. I hope you like these 10 questions and I hope you practice this 10 question for your gate preparation. So see you with more videos and for more subject to solve, more questions to solve. So see you in my next video. Thank you. So subscribe my channel and share with your friends and like my videos. So thank